There are some homework problems in your thought primer that almost always throw some number of people for a loop, causing them to spend way more time on their thought primer than they need to and get way more frustrated than they need to, because these are actually fairly simple, straightforward problems. And what I want to do here is to show you the strategy for approaching these problems. These problems in your thought primer involve you examining a pair of given premises and using a Venn diagram to determine if any conclusion follows with logical necessity from those premises. Okay, so it might be something like this. Here we have two premises. Premise number one, all guys in fraternities are fun guys. Premise number two, no guys who have mullets are fun guys. And what we want to know is, okay, does any conclusion follow with logical necessity for those premises? And what we're going to do is we're going to represent this argument symbolically. We'll use F for fun guys, G for guys in frats or fraternities, and M for guys with mullets. And now the argument looks like this: all G or F, no M or F. Does any conclusion follow from that? We're going to use our Venn diagram to answer that question. So we're going to mark our two premise statements. So to show that all G or F, we're going to have to eliminate areas 6 and 7 as areas open for membership, because all the G's, if all G's or F is true, then they'd all be up here in area 3 and 4 and not in 6 and 7. Now we can mark our second premise, no M or F, so we're going to have to eliminate areas 2 and 3 because those are areas where the M and the F circle overlap, and if no M or F, there can't be anything in there. Okay, now we've marked our premises. And what we want to do is we want to look at this Venn diagram to see, does it show any other standard form categorical statement in addition to the two premises that we just marked? Now, there's a couple of things you want to notice here. One is, in standard form categorical syllogism, each term appears exactly 2 times. Okay, we have 3 terms that appear 2 times. And you can see here that the middle term, F, has already made its 2 appearances. So whatever statement we're looking for, whatever potential statement we're looking for, it's not going to involve F, because we can't use the F term anymore in this categorical syllogism. Notice, though, that G and M only appear once. That tells us that the conclusion statement is going to be about G and M, if there is a conclusion statement here in this Venn diagram. And we know that the subject term of the conclusion is our minor term, which is M, and we know that the predicate term of our conclusion is the major term, which is G. So we're looking for a statement about M and G, and the easiest way to figure out if this Venn diagram reflects any statement involving M and G is just to run through the possibilities. For example, does this diagram show the statement all M or G? Are all the M's also G in this Venn diagram? And we'd say, well, no, actually. If any M's were G's, they'd be right here in areas 3 and 6, and the lights are off in 3 and 6, so there's nothing there. In fact, all the M's are over here in area 5, and that's outside the G circle. So this Venn diagram does not show the statement all M or G. So then we ask the next question. Well, does it show no M or G? Does it? Yeah, it does. All the M's are here in area 5, and everything in area 5 is not a G. Everything in area 5 is excluded. It's outside of the G circle. So these two premise statements, when we assume they're true, by logical necessity, they lead to the conclusion no M or G. And so that's what we'd identify in this problem. Now, you might be thinking to yourself, well, wait a minute. Isn't it possible that we could put a circled X here in area 5 or maybe even area 4? Because those are the only areas of those circles left open where anything can be. And when I operate from the Aristotelian standpoint, I get to mark an X with a circle around it when I have a circle of my Venn diagram that has only one area remaining open for membership. But here's the thing you want to think about. Yes, you could put a circled X there, but you really don't need to, and here's why. No M or G is a universal statement. All M or G is also a universal statement, and universal statements communicate much more information than their corresponding particular statements. So no M or G tells us something about every single M, but the statement some M are not G, that tells us about at least one M, but we don't know how many more. But the M or G, no M or G is telling us about all the M's, okay? So whenever we have the choice between having a conclusion statement that is universal or particular, if they both work, we're always going to opt for that universal statement and not the particular statement, because that allows us to communicate more information. All right, let's do one more. Here is our premises. All photos of kids with the Easter Bunny are cute photos. All vintage photos of children are cute photos. What I want you to do is I want you to pause your video. I want you to use the strategy I just laid out for you and determine whether or not any conclusion follows from these two premises. And when you're ready to check your work, go ahead and restart your video. I hope you paused your video and did this work. Otherwise, I'm sitting here in silence like a bit of a tool. All right, so let's check your work. Okay, we represent this argument symbolically, and if we use E for photos of kids with the Easter Bunny, and C for cute photos, and V for vintage photos, we're going to get the premises looking like this: all E or C, all V or C. So you might have chosen different letters. That's okay. You just want to make sure that your middle term is over here in figure 2, in the predicate of both of these. When we mark our Venn diagram, we mark all E or C by eliminating areas 6 and 7, and all V or C by shading in area 5. And our Venn diagram looks like this. Now all we have to do is remember, we're looking for a statement about V and E. We're looking for a statement that has V as its subject term and E as its predicate term. And we'll just run through them till we find one that shows is reflected by this Venn diagram. Does this Venn diagram show all V or E? No. Because there could be V's over here in area 2, and those would not be E's. So this Venn diagram does not reflect the statement all V or E. So that conclusion does not follow from these premises. How about no V or E? No. Area 3 is unshaded, so there could be V's there, and if there are V's there, there are also E's. So this does not show no V or E. Does it show that some V or E? Well, that's an obvious one, because if it did, we'd see a plain X somewhere. And it doesn't show some V are not E. Again, because we'd see a plain X there. And even if we considered this from the Aristotelian standpoint, we're not going to be marking a circled X anywhere, because all 3 of our circles have have 2 areas open for membership. There's none of our circles have just one area unshaded. So what we say in this case is, you know what, I've taken your premises into consideration. They don't lead anywhere. They don't lead to any conclusion. There's no conclusion you can draw from these 2 premises, and we've just proven it with our Venn diagram. All right, so that's how you're going to approach these problems in your thought primer homework.